What's up guys, Cwesolo here, and today we are back for another How to Code in C# video. Today we're going to be covering linked lists. I'm going to be discussing how they work, what they do, and I'm going to be comparing them to a data structure that we've already covered, arrays. Linked lists and arrays are pretty similar and they solve a very similar issue. The issue of I have a list of numbers or of any data type, whether it be bool or floats, or it can be a list of classes, right? We have some list of some data that we need to store in, and we need to have a list of it, right? They both solve this issue, but they both go about it in fundamentally different ways, and they do both have their advantages and drawbacks of each other. So you may want to use one over the other in certain scenarios where it may be smarter to use a linked list for one situation, and another situation it may be smarter to just use an array, right? So yeah, we're going to discuss that in this video, and I'm going to go over their drawbacks, how they work, how to use linked lists, and compare between the two. And we're going to discuss how they work too. So first things first, we're going to discuss how they work. So we're going to get right into that right now. Linked lists work by having nodes reference the next node. So basically, like, you have a class that is a node and that contains the data that you are storing, right? So say we are going to store ints, right? So we're going to store a number, and each node stores the data that we need to store, and then it stores a reference to the next node. So it points to the next one in the list. This allows linked lists to be able to be any size. Linked lists don't have any cap on how big or small they need to be, unlike arrays where the size is predetermined, right? So you predetermine an array. For example, right here, our integer array here is of size 10. We can only fit 10 values into this integer array. Where if we make a linked list of ints, right, we can put as many values as we need into this list, right? It can be as big as we want it to be, and we never have to copy and paste the values from one array to another to expand the array. It's just self-adjusting in terms of size. Its size can vary, right, as we remove and add items to our linked list. But the issue with this is that to retrieve data from a linked list, you have to go through each node to find the data you're looking for, right? So it's going to be O of n time complexity to retrieve any item out of a linked list, right? So you have to go through the first node, second node, third node, fourth node to get the data out of the fifth node, which is the one that you're wanting to get the data from, right? Or whatever node it may be. So that's really how linked lists work, and that's how they're able to self-adjust in terms of size, is that it's just nodes that are connected to each other. And it's really just keeping track of the memory addresses of each node, that the memory address to the next node. So yeah, that's pretty much how they work and what they do. So with that being said, let's get right into this. Let's start working with linked lists. So I made a class, it's called lists, and we're gonna go over the differences between arrays and linked lists, and we're gonna go ahead and make them. And I'm gonna kind of show how linked lists are able to be self-adjusting in terms of length, where arrays, you kind of have to manually expand them if you need to add more elements to an array. So I'm gonna go ahead and write some code here for the use array method here, and then I will write some code for the linked list method here, and then we'll just go through the code for each of them. Okay, so as you can see here, I have some code here for the use array method and the use linked list method here in this class. Pretty much here, so we have an array, so it's just an integer array. We're gonna iterate through and just fill the array with just 0 to 10. And then I'm printing the length of the array out, and as we can see here, I have to resize the array to increase its size. If I don't do this and I say I want to add an element to the array at, say, 11, and set it equal to 1, this is going to cause our program to blow up. We're actually going to have an error, and I could prove this to you by calling this method, and we'll go ahead and see what happens here when we try to add an item to this one. So we get an exception, so we get a system index out of bound exception, which basically means your array is not big enough to take in an 11th value, right? We're trying to address memory that is not inside of this array, right? And considering arrays are continuous memory, it's trying to access something that is outside of that memory block. So we can't actually set it equal to anything. We can't pull anything out of there. It just won't let us. We'll get an exception for doing so, right? So in order to fix this, is we have to resize the array, and then we can add this value, say this value number 1 to the array, right? So we can go ahead and resize it to 20 and then try this again, and we won't have any issues at all. See? So as you can see, we have our length increased from 10 to 20, and we have taken in this value. And we can even print this value too if we want, as well. It's showing that we have the 11th value in there. So we can grab my array at 11, right? And we could just print that value for us to see that it is 1. See? So we made it equal to 1, and we just printed that value here. So with the linked list, I filled it with 10 items, and I printed the count here. So as we can see, the linked list is self-adjusting, and the linked list class in C# has lots of different methods that come along with it. If we check here, our methods, and I'll show you how to get things out of it and remove things too, but there are lots of methods here to use. So I would suggest, if you're going to be using it, go check the Microsoft documentation and take a look, because there's a lot of methods here. There's methods for finding the max, the min. They have methods for converting this to an array. So if we ever need to take our list and transform it into an array, we can do that, or a hash set or a dictionary, depending on what we need to do. We can do a lot of these different things to find out what we needed to do. We also have different methods for finding different values in the list as well. So like find last, or we could find the first value. I'll show you those as well. So that way we can get, you know, the first and last values. But either way, I did want to cover the fact that these are self-adjusting, so we are able to add things and not have to worry about having to resize it, because linked lists, as I've mentioned, just have a reference to the next node in the list. So we don't ever have to add or expand the size of our list, because it self-expands itself. So we'll go ahead and do that real quick, and I'll show you by using this use linked list method here back over in our initial file here. And as we can see, we'll use it, and now the size is from 10 to 11. We never had to resize it, and we can continue to add values to this, and it will never matter. To get an item out of the linked list, so say we wanted to print the 5th value in our linked list. We're going to want to go ahead and grab the value from the linked list. So we're going to do a console.write line. We're going to go list.find. And this is going to find the value that we're looking for. And then we're going to want to do value. And this is going to get the number 5 out of there. This is the 5th element in our list, but this is the find value finds the first one in the list. So if you have multiple of the same value in the list in several different spots, it's going to find the first one and pull that. So this is going to find the first 5 in there. If I were to add last, and I were to add another 5 in here, there'd be 2 integers with the number 5 in this list. This will just grab the first one. If we want to print so we can do that, and we'll go ahead and run this again. And as you can see, we've grabbed the number 5. We can also grab the first value in the list too. So if we want to grab we want to find out what's the first number in our list, we can do that. So we can do list.first and then value. So we're just getting the value out of the first node in this list, and it should be the number 0, because we have stored 0. And as we can see, it is the number 0, because when we added our values into our linked list, we used add last. You can also, there's also another method to add things to the list too. So if you want to add a value in between 2 values, you can do add first. So they have add first. So if we want to change what the first value in our list is, so say we want to change it to some other value, we can go ahead and do that. So we can go ahead and do list.add first. So add first, and we could add, say, I don't know, the number 1000. We're gonna add number 1000 to our list. So 1000 is gonna be the first value in our linked list, and we're gonna just print that now when we do this console.write line. As we can see, 1000 is the value that gets returned when we add first. Add last adds a value to the very end of the array. The list. If the list is empty, add last will add as the very first element in the array list. So that is worth noting, that it just adds the element to the very end. If we want to add something in between 2 values, we can do list.add_before, and we need to get the value that we want to add it before. So we're going to go ahead and go list dot find, and we're going to find the value 4 and list and we're gonna go ahead and add the value, I don't know, 6. So we're gonna add the number 6 before the value 4. So this is gonna find the where 4 is in our linked list, and then it's gonna put the value 6 before it. And if we go console.writeLine and we look for, we're gonna look for find here. We're gonna find the value 6. We're gonna print it. We're gonna look for that number now. So as you can see, we print the number 6, and we have found that number in there. So if we need to add between two numbers, we could add it before, or we can do add after. And we could add it after a number. So say we want to add a value after the number 6, so we could find. So list.find. We're gonna go ahead and do 6. And we're gonna add the number 9 there. And now we have added a number after 6, but before 4. So this is kind of confusing because we added 6 to before 4, and now we're adding a number after 6, which is kind of cool. And if we were to go ahead and print this whole list out in the in pretty much in order, so if we go ahead and just iterate through the whole list, we can print each value. So now we're gonna go ahead and print through each value in the list using a for each loop. So we're taking for every int in the list, and we're printing those to the console. We can see our we have an interesting thing here. So we have 1,000, and then we have 6 here. So we added 6 before the number 4. Then we added 9 after 6. So we have 2 numbers before 4 now. And then it continues on adding on to the list. And you can see that this list is self-expanded. So even if we were to go ahead and do a count again, so if we were to print the count of our list has gotten bigger. Now the size is of 14. So yeah, that's pretty much how linked lists work, and how you can add in stuff, add values wherever you need to put them, and see how it self-expands. It is worth noting that I mentioned before that to find a value in the linked list, it is O of n time in terms of time complexity to find the item, because it has to go through each node to get to the node that contains the number that we're looking for, or whatever data type you're using. If you're using a float, it's gonna be like that too. So it'll be whatever contains that, right? Another thing, removing items from the list is fairly easy too. So say we want to remove an item from the list, so we want to do list remove, and then we just type in the value we want to remove. So we're gonna just remove 1,000. If we cannot find the value, it'll throw an exception. So if you type in a number that's not gonna be removed, or a number that's not in the list that doesn't exist, it'll throw an exception. You'll get an error. But we're gonna remove 1,000, and then we're gonna go ahead and print the first value again, and it should go back to 0. So we're gonna go ahead and print the first value after we've removed 1,000, and now the value is back down to 0. So the first value in our list is now 0. So that's how you remove an item from the list, and the list will self-adjust, and the count will also decrease as well as a result. So if we also print the count, once again, it will be less than what it was. And now you can see this was the old count at 14, and now it's 13. So self-adjusting in terms of size. We could put as many elements as we want in here and keep expanding this list. And this is good for storing data that we don't exactly know how many items we need to store into it. We just need to continuously store data. There is one drawback of the fact if you're constantly grabbing the data from this list, it will take some time because it is O of n time complexity. So you'll have to iterate through every item in the list until you find what you're looking for. So that is worth noting. If you are constantly having to query this list for data, you might be better off using a different data structure if you're constantly having to pull data from it all the time. It might be better off using an array, because an array is better suited for constantly having to pull data from it, because it is O of 1 time to get, if you know what you're looking for, to pull that out, if you know exactly what index it is at. So, but again, if you need to find data from an array and you don't know what index is at and you're looking for a specific number, you'd have to iterate through the whole thing. So it's kind of similar in a sense, but no matter what, even if you know what data you're looking for with the linked list, you are going to have to search through it using a for loop. Again, like I said, this is all done for us with the find method, so it finds what we're looking for. So yeah, the find method handles all that. But yeah, that's pretty much it for this video. If you found it helpful, leave a like, comment if you have any questions or anything like that. I hope this helped you out, and there'll be more videos on how to code in C# soon. I'll see you guys in the next video. Peace out and have a great day.